Okay, so welcome back, class. So what I did was we're going to talk about the polar coordinates. We're going to look at the polar plane, okay, and how do we set up the polar coordinates and how do we use those, okay? So, for example, if I wanted to plot a point, and I put a point up on the board, and in this point here, this is where we use the polar coordinate system. Okay, this is the setup. Okay, so just like we have a setup with a rectangular coordinate system, this is the setup for the polar coordinate system. Okay, so notice one, this is the polar axis. This is what we call the positive x-axis. So I'm going to make some comparisons between the rectangular coordinate system, the Cartesian plane, and the polar plane. So what we normally call the positive y-axis, that's going to be the polar axis. That's when the angle is 0. Okay, so that's 0. Okay, so remember the two pieces for a point is the radial coordinate and the angular coordinate. So the r and the theta. Okay, so r is the distance the point is from the origin. So this is what we call the origin in the rectangular plane, but this is what we call the pole. So the origin is what we call the pole in the polar system. Okay, and then we have each one of these tick marks represents the length along the polar axis. Okay, so that's going to distinguish our length of the ray or this line segment from the pole to the point. And then of course each one of these lines going up around this circle is the angle, theta. So this is the angle, pi over 12, that makes from, this is the terminal side, so this is the terminal side and the polar axis, so that creates an angle with the center. And so that's what theta is. And so we see that as we go around the circle, this creates a larger and larger angle with the terminal side. So this is pi over 12, pi over 6, pi over 4, and these are all the common angles. These are all the most common angles that you're going to run into that you'll be able to know how to handle these right away. Okay, again, these are the common ones. So again, pi over 12, pi over 6, pi over 4, that's 45 degrees. This is 30 degrees, right? 45 degrees, 60 degrees, oh boy, I forgot what that was. Pi 12 over, 5 pi over 12, and then of course 90 degrees, right? So 90 degrees, and then starts over, okay, it keeps going. So it always goes up by 1/12 of pi, right? So each one of these lines is 1/12 of pi, so it's increasing by pi over 12, okay? In fact, that's, if you put all these under a common denominator of 12, you'll see that it goes from 1 over 12 all the way to 24, right back to where you started, 24 over 12, which is 2 pi, right? So it goes from 0 all the way around to 2 pi, okay? So again, I'm showing you this because I want you guys to memorize this. You're going to want to memorize this thing, okay? And you're going to want to be familiar with the unit circle and these angles. So now, another thing to realize is that if I take the point 2 pi over 3, so again, 2 pi over 3 is right here. So that's going to be approximately, if I was to, how do I want to do this? So to draw the circle, so 2 pi over 3 would be right about, would be there. So that would be the point 2 pi over 3, so that would represent this point. But also realize that if I said, okay, well let's do 2 and let's do 7 pi over 3. Now that represents the exact same point. It does. Or if I want to do, what about if I want to do, what if I do, let me see here. Let's see. What if I do that? I could have a negative, right? So I could have a negative value. So I could go -2, which would be actually right here, but my circle. So if I go -2, and then I do 4 pi over 3, let me see if that'll work. Yeah, so if I do 4 pi over 3, which will be what? Pi plus another pi over 3, which would be right here. And then if I go negative, right, so 4 pi over 3 would put me here. And then if I do -2, I jump across in the opposite direction. And I get to the same place. Okay? So there's an infinite number of ways I can write the same point on the polar coordinate system. Okay? In fact, any multiple of 2 pi will get me right back to the same place, because if I go 2 pi, that's 1 revolution. So every time I add 2 pi, I'm going to go back. So if I add 2 pi, I get 7/3. If I add another 2 pi, I get 13/3. Or excuse me, is that right? Yeah, 13/3. Okay, and if I add another 2 pi, I get 19/3. Okay, so every time I add 2 pi to the angle, I'm going to go around 1 time and end up right back where I started. Okay, and so I can do the same sort of thing with, if I do negative and I do this, I can keep adding 2 pi to this. Oh, and I can go the negative direction too, right? So I could do negative angles as well. So there's lots of different ways to represent a point. Okay, so that's one thing to keep in mind. Okay, what else? Okay, so let's plot some points. Okay, so here's an example. Let's plot the following points. So let's do 2 pi over 4. 2 comma pi over 4. Okay, so 2 comma pi over 4. Okay, where's that going to be? Well, 2 and then pi over 4 is right here, right? 45-degree angle, so it's going to be right there. What's the next one? What about -3, 2 pi over 3? So we're going to do -3, right? 2 pi over 3. Okay, well, let's see. We can do -3 and then 2 pi over 3. Well, where's that at? 2 pi over 3, well, we can go 2 pi over 3, which is right here. Boom. And then we can do opposite, -2 or -3, which would put us right about here. right? So let's do that. That's negative 3, 2 pi over 3. Or we could do 2 pi over 3, right? We did 2 pi over 3, right? We did 2 pi over 3, which basically put us right here, okay? And then we flipped it over here. Or we can do 2 pi over 3, or we could do negative 3, right? And we put us here, and then do 2 pi over 3, which would put us, oh, hold on a second. Oh, I did the wrong one. I flipped it on the wrong side. Sorry. Oops. Okay, let's try that again. Okay, so the first way I did it was, let's do 2 pi over 3. So 2 pi over 3 is right here. And if we flip across, it's right here. This is across. Again, you'll have to forgive my drawing. It's not the best. So 2 pi over 3 is across is right here. So it should be right about there. So I could go 2 pi over 3, right? I could go 2 pi over 3, which would be here, and then go negative 3, which would jump across to here. Or I could do negative 3, which would be here, and then go 2 pi over 3 angle from here, and so that would put me at the same spot. Okay? Okay, next one. What about 4 comma 5 pi over 4? 4 comma 5 pi over 4. Okay, so now we're going to go to 4. That's how long it is. 4 units from the origin, or from the pole. And then we're going to go 5 pi over 4. Where's 5 pi over 4? Well, 5 pi over 4 is right here. So we're going to go all the way around to 5 pi over 4, which is right here. And that's going to put us at 4, which is going to be 1, 2, so 2, 3, 4. Let's say right about here. Okay. And again, I could do many different ways, right? So we've got that one. Okay, and let's do a couple more. Let's do 4 5 pi over 3. So 4 comma 5 pi over 3. So again, 4. Now we're going to go to 5 pi over 3. Well, where's 5 pi over 3? It's right there. So now we're going to go to 4, 5 pi over 3. So we're going to go to 4, which is going to be right about there. And one more. Let's do negative 3. Oh, this is a good one. I like this one. Let's do negative 3 comma negative 7 pi over 2. So now we're going to go negative direction. So that means we're going to go clockwise. So now what we're going to do is we're going to go negative. We're going to go clockwise. So the negative sign means we're going clockwise. If it's positive, we're going counterclockwise. So we can go negative 3. So again, there's a couple different ways we can do this. We can go negative 3. So 1, 2, 3. And then we can go clockwise 7 pi over 2. Okay? So 7 pi over 2 is what? That's going to be Where's 7 pi over 2? 7 pi over 2. Okay, there's no 7 pi over 2, but guess what? If we change that to a 12, by multiplying the top and the bottom by 6, we get 42 over 12, which means we're going to count 42 of these lines, okay? Because each line is 12, okay? So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. So negative 3, comma, negative 7 pi over 2 is right there. Now, there was another way we could have done this. Remember, each pi over 2 is 90 degrees. How many times are we going to go 90 degrees? 7 times. So if we start with negative 3 and we go 7 times, what are we going to do? We're going to go 1, 2, 3, 4, 5, 6, 7. And we get to the same place. Okay? Or we can divide into 2, and how many times does 2 go into 7? 3 times. 3 pi is what? 3 pi is 1.5 revolutions, right? So if we start here at 3, we're going to go 1, 2, and then a half of pi is 90 degrees, and we get to the same place. So again, there's many different ways to kind of think through these mentally. Okay? And that's it. So again, this is the way we use the polar system. Next, we're going to talk about polar curves. See you next time.